Hello friends, welcome to my channel. Let's have a look at problem 2529. Maximum count of positive integer and negative integer. In this video, we're going to explain a solution based on binary search. So this video might be regarded as a follow-up video for that on problem 704. Right? So 704 is today's daily challenge problem. So in this problem, we are given a sorted array called nums. So we want to return the maximum between the counts of positive integers and negative integers, right? So here it specifies that 0 is neither positive nor negative. So there are several examples. Let's look at example 1. So we have 3 negative numbers and 3 positive numbers. So the output is 3 because the maximum of 3 and 3 is 3. And in the second example, we have 3 negative numbers and 2 positive numbers. So the larger is 3, so we return 3. And in the example 3, so we have 4 positive numbers and 0 negative numbers. So the return is 4. So with that said, let's also look at the constraints. First, the length of this array or list is bounded below by 1. In other words, it's not empty. And bounded above by 2000. So this 2000 actually is not very large. So basically, if we do not want to solve this problem in logarithm time, so we can do a linear scan to check to find the first the number of positive numbers and the number of negative numbers and do comparison, right? So the second item is that so the elements can be negative, can be 0, and can be positive. The last one, nums is sorted in non-decreasing order. So this assumption basically enables us to use binary search. So with that said, let's look at the treatment. So here we are going to use binary search. So if you or we have practiced quite a lot on binary search, we know that binary search is related to O logarithm n time complexity, where n is typically the iterable length involved. So this basically we are talking about the vanilla binary search. So sometimes based on different problem situations, the binary search can be logically interesting and complex. So here we're going to use the bisect module in Python. In the previous video for problem 704, we mentioned this module. So here the thing is that we are going to use the bisect module to determine the insertion point for 0. Then because the thing is that numbers strictly less than 0 are negative numbers, and numbers strictly larger than 0 are positive numbers. So now let's look at the coding to encode all this information. So here I'm going to retrieve the length of this nums list. So introducing this variable n is not necessary, absolutely necessary, but it brings us some ease of typing, but it's also a personal preference. So this is the first thing. And then what we are going to do, I'm going to get the index for the insertion. So here I'm going to use the bisect module and use first the bisect left. So the iterables is a num. So the target number we're going to check insertion point is 0, right? So basically we want to check if we want to insert 0 into this sorted iterable, and then what's the position. So here we're using bisect left, which means that so nums I is less than, strictly less than the target 0 if so this I is left to the index. So a special case is that the IDX negative is 0, which basically means that in this list there's no negative numbers. So this is the one line. Another line we are going to consider is positive, the index positive. So here I'm going to use the bisect right. So this I'm going to check 0 again. So the bisect right function makes this happen. So I is greater than 0, strictly greater than 0, the target, if I is greater than IDX positive. So again, a special case is that this IDX positive equals to m. So this corresponds to the fact that there's no positive numbers. So now with this explanation, we know that the negative numbers in the nums list is this, count as this, and the number of positive numbers is n minus IDX positive, right? So notice that it's not n minus this index, negative index, right? It's n minus IDX positive. What's the reason? The reason is that in the nums list, so there are possibly zeros, right? So the problem requires us to return the max of this thing, right? So now this snippet of code forms a solution format to this easy problem. So before we make any comments, let's first do a test. Yeah, it passes a test case. Now let's look at the generic case. It passes all the generic cases. So first, I would like to comment that this code basically is a translation of the problem statement. So here I get the number of negative numbers, and here with this one and this one we get a number of positive numbers, and then we return the max of the two. So basically you can regard this as a translation of this statement. So this is the one thing. Another thing is that here we are using the bisect left and bisect right function. So actually it's a good practice to try writing these utility functions ourselves. This is actually a lot of fun, especially when we can understand the paradigm in a higher level. So this is the second thing. And the third thing is about term complexity. So this is still some easy use cases. So here we call this function bisect left and bisect right here. So both the two functions have term complexity O logarithm n, where n is the length of the nums iterable or list. So overall, it's a big O of logarithm n, right, in term complexity. So that's the last comment. So with that said, I guess that's about it for this specific problem. I would say it's a good practice for the usage of binary search. So if you found this explanation useful, you're welcome to follow up my YouTube channel. And with that said, that's about it. Thank you.